Once again, very welcome, my dear friends. We know that in our previous lecture, we have just started the chemical reactions of phenol, in which we have took the first reaction, that is nitration of phenol. We know that in that case, that is in case of nitration of phenol, firstly we use concentrated HNO3 as well as dilute HNO3. It means we have reacted, or we have seen the reaction between phenol and dilute HNO3, as well as we have seen the reaction of phenol and concentrated HNO3. When phenol reacts with these two, we know that we obtain different products. Like that, the sulfonation of phenol, that is our second reaction, gives different products at different temperature. And now likewise our nitration and sulfonation, halogenation, our next chemical reaction on phenol, also gives different products. Now for that we have to see our halogenation. In case of halogenation, when phenol molecule is treated with concentrated H2, in case of halogenation, when phenol molecules is treated with, for example, bromine molecule, but in presence of polar solvent, here we use water molecule as a polar solvent. In this case, this phenol will give 2,4,6 tribromophenol, whereas if this same phenol is treated with same bromine molecule, and if we change this polar solvent by non-polar solvent, now when the same phenol molecule is treated with or brominated or undergoes bromination, but in presence of non-polar solvent like CCl4, then we obtain mixture of product, that is orthobromophenol and parabromophenol. Here, when the same reaction, that is bromination, is carried out, same phenol, but in presence of what? Non-polar solvent, then we obtain mixture of product, that is orthobromophenol and parabromophenol. Out of these two, this parabromophenol is obtained in major extent. This is all about our halogenation, here bromination of phenol by using different types of solvent, that is by using polar solvent as well as non-polar solvent. Now the next reaction of this topic is nothing but Nitro Association. Now Nitro Association means addition of NO group. For that purpose we have to use NaNO2 plus H2SO4 Now the mixture of these two will generate HNO2, that is nitrous acid. When the Nitro Association of phenol is carried out, at that time the temperature of that reaction should be maintained below or equals to 5 degrees Celsius. It means this reaction is carried out at low temperature. Now when this phenol molecule is treated with NaNO2 plus H2SO4 at 5 degrees Celsius, we obtain para-nitrosophenol as a compound. This para-nitrosophenol, which is obtained as a product, is formed exclusively. It means it is the only product. In this case, there is no chances of formation of ortho product. That is, it is our next reaction on phenol, that is Nitro Association. Okay. Now the next reaction, this carbonation means addition of carbonyl group, addition of CO2 group. Now it is also called as Kolbe's synthesis. In this Kolbe's synthesis, when phenol molecule is treated with carbon dioxide, in presence of base, we obtain salicylic acid as a product. After the acidification condition. This is the simple reaction of Kolbe's synthesis. Now the carbon dioxide molecule used as a electrophile in this reaction. Now moving towards our mechanism of Kolbe's synthesis, step by step we will understand that how this reaction proceed in forward direction. Now, mechanism of Kolbe's synthesis. Firstly, phenol molecule is treated with sodium hydroxide. We know that this sodium hydroxide is a base and OH negative ion abstract this H positive to form sodium phenoxide ion. Now this O negative ion, that is phenoxide ion, will attack on the electrophile CO2 molecule. To form this ion. The intermediate undergoes rearrangement to give sodium salicylate. Now this molecule undergoes rearrangement to give what? Sodium salicylate. Now this sodium salicylate undergoes acidification to give salicylic acid as a product. To give salicylic acid as a product. This is Kolbe's synthesis. Now the next reaction of the chapter is nothing but Riemer-Tiemann reaction. Now Riemer-Tiemann reaction is used to prepare salicylaldehyde, in which phenol molecule is treated with chloroform in presence of alkali, that is NaOH, in presence of base, to give salicylaldehyde. When we deals with the mechanism of this Riemer-Tiemann reaction, we come to understand that the reaction between these two, that is chloroform and sodium hydroxide, will generate dichlorocarbene, and this dichlorocarbene acts as a electrophile here. It means this dichlorocarbene acts as a electrophile in the mechanism of this reaction. Now the mechanism of this reaction, we know that this is our phenol, and phenol carries, the oxygen atom of phenol carries a lone pair. Now the lone pair delocalizes in this ring, and this pi electron will attack on our newly generated carbene molecule to form this compound. Now this carboanion, which is formed in first step, will accept this proton to restore the aromaticity of this ring. Now this dichloro compound attacked by the base to form 1,1-diol compound like this. Now finally this 1,1-diol undergoes deacidification to give, or removal of water molecule to give our final product, that is salicylaldehyde. This is all about our Riemer-Tiemann reaction, and this is all about our today's lecture. Thank you.